Let's look at the two-sample t-test using this example on slide 2135. Okay, we're told that we have some data in a file called concrete breaking strength, and that there are two different types of concrete mixture, one of which is a 301 and the other one is a, 400. Okay, so we've got 9 cylinders of the 301 concrete mix was poured into some sort of cylinders, and another 10 of the same size of concrete 400 mixture into another. Alright, 19 cylinders were allowed to set for 28 days, and the breaking strength was measured. So in our data file, we're going to have the breaking strength. Now, anytime we are comparing two groups, and these two groups, by the way, are independent, we have a set of concrete that's mixed up under one set of specifications. We have 9 test cylinders that we're going to look at the breaking strength, and then another completely different mixture was made up, the one with the 400, and they had 10 cylinders that were filled and set to harden. Okay, let's have a look at how we would do this question in Minitab. I've got the data opened up here, and there are two different sets, and my sample sizes are different, 9 in one, 10 in the other. That's perfectly allowed. Alright, the test is under the Stat tab, Basic Statistics, and we are using the two-sample t, and as the little blurb here says, determines whether my means differ significantly from each other. Alright, you have to pay attention as to how your data are set up and how you define the difference. Now, the default is that both samples are in one column, which at the moment we don't have. We have each sample is in its own column. And in the example, the question was, I may have to go back here one second. The question was to determine whether the 400 mixture has a higher breaking strength than the 301 mixture. And as I said here on slide 37, I would set that difference as the 400 minus 301 because then I'm expecting a positive difference. The question is whether the 400 breaking strength is larger than the 301 breaking strength. And you should, as practice, set up your differences as a positive. It just makes it easier on your brain. Okay, so coming back into Minitab here, I'm going to pick my 400 mixture first. So Minitab will take the 400 mixture minus the 301, sample 1 minus sample 2. I would go to options for this. I want to know, first of all, my hypothesis is that there's no difference. The difference is 0 between the two groups. And I wanted to know whether or not the difference was a positive. In other words, was the 400 greater than the 301? At the moment, I have no idea if the variances are equal, so I'm going to leave that turned off, but I will come back in and turn that back on. And to see whether or not equal variance is a reasonable assumption for these data, it's smart to have a look at a box plot. Okay, now here are my box plots, and overall the spread of the data from Q1 to Q3, so the length of the box right here, is roughly, it's not exactly, but it's roughly the length of this box, and from the min to the max, that total spread is about the same as the min to the max right here. So this looks more or less like the overall spread of these data is about the same for both groups. So we could assume equal variance, but we'll do the test two ways. The other thing to note here is that in general, the 401 mixture tends to give me higher values. It's got a higher min, Q1, a higher median, a higher Q3, and a higher max than does the 301 mixture. So when I look at my results, it won't really be a surprise if the results tell me that this concrete mixture overall has a higher average breaking strength than this one right here. Okay, I look at the results from what Minitab gives me, and okay, I've got the 400 mixture right here minus the 301 mixture. Go back and check and make sure you've set this up the correct way. What is the difference in these average breaking strengths? I got a 4483 and a 3669. The difference is 814 pounds per square inch. Really what I want to know is that a big enough difference? Is it significant? My null hypothesis is that there's no difference versus that the 400 is larger than the 301. Minitab calculates her test statistic. It gives me 16 degrees of freedom. And that 16 degrees of freedom is based on that rather convoluted formula, I think on slide 21-23. Gives me the p-value rounded to 3 places after the decimal, and I want to know, is this p-value less than alpha? And I forget in the problem. Let's go back and have a look just 1 second. What did the problem ask us to compare our alpha to? I need to go back up here. We are asked to run the test at an alpha of 0.05. So all right, we got to compare our p-value to 0.05. So if I go back into Minitab right here, is this number a smaller number than 0.05? Answer is yes. Therefore, I would reject this statement in favor of my alternate. What does my alternate really say? It says that the 400 mixture has a higher breaking strength than the 301. Okay, now when I ran that test, I ran it assuming that the variances were not equal. I could go back in here and under my options, I could tell Minitab to assume that the variances are equal. Click OK to this. Oh, I'm going to turn my graphs off because I don't need to see that again. And my results look pretty much the same. If I scroll down, let's see, I got a test statistic of 3.8. Down here I get a test statistic of 3.8. You won't always see this, by the way, but in this example you do. I get the same p-value, and the only difference here really is in the degrees of freedom. Now, how do I know that this thing is using the pooled t-test? Because I get this little bit of information right here, which calculates the SP value. That SP value is referred to as the pooled standard deviation. When I run the test without the assumption of equal variance, I don't get anything in this result right here that tells me that it's using the pooled. So this one is what I would call the unpooled test. This one down here is the results of the pooled test. Both of them tell me the same thing in this particular example.